Okay, minimum value of p. You should be thinking when you see a function like this where we're calculating a minimum or a maximum, it's differentiation, optimization. First thing I do is I write down all the equations that I'm going to need for the question. Hence, so bad equations. So the first one I know is that p is equal to 2x, so that's the perimeter. And that's the perimeter p of the sector is given by this, okay? And x is the radius, right? Now I'm just going to rewrite that. So I'm going to put a little dot here. I'm going to say that's the same as p equals 2x plus 128 x to the negative 1. So all I've done is just rewrite that because I want to differentiate that. And now if I differentiate it, I'm going to get a 2, take away 128x, take away 2. I've multiplied these, take away 1. At this point, again, I'm just going to write it nice. I'm going to say that p dashed is therefore equal to 2, take away 128 over x squared. And I'm going to double differentiate. So the 2 disappears, and that's going to be 256 x to the negative 3. So times them together, we get a positive, this disappears. And take away 1 for negative 3. So then if I write that nicely, and when I say nicely, I mean in a way that I could substitute in and it would make sense. You know, on the right there, I can't really do substitution, but on the left here, I can. That's over x cubed. So that's me got all the things I'm going to need. And I do the double differentiation instead of a nature table for the. Well, in fact, we'll come to that later. So the next thing I want to do is minimum value. Okay, the minimum. So if I'm looking for a minimum value, that means that p dashed or dy by dx, whatever, has to equal 0. So that is equal to 0 for stationary points. Okay? So if I've got a graph, I'm looking for the minimum value at that stationary point, that lowest point, I'm going to have a gradient of 0. So I'll take this and I'm going to put that equal to 0. And this is where I'll use the nice one. This is more for the differentiating. This is for the rearranging. So I'm going to say that 0 is equal to 2, take away 120 over x squared, and then I'll just rearrange. So I'm going to add that 120 over x squared to both sides, then multiply by x squared. Then I'll divide by 2, so that's 64 is equal to x squared, so then x is equal to 8, or negative 8. Now at this point I'm going to cancel out negative 8 because we can't have a negative radius, okay, so that doesn't make sense. And the next thing to do is just to double check the nature as well. So I think I'll just go over this right here for that. Just verify the nature. So verify the nature, I take my equation, I take the p double dash, which is 256 over x cubed. So p double dash is 256 over x cubed. And where p double dash is greater than 0, we have a minimum turning point. When p double dash is less than 0, we have a maximum turning point. And the way I remember that is, this is a bit like saying, you know, that'd be a positive x squared. This would be a negative x squared. So if you get a negative number, I think negative x squared max. So we're just going to double check we've got a minimum turning point. So p double dashed is equal to 256 divided by 8 cubed. And that is going to come out as a positive number. It can't be negative. We'll just do it actually. So that's 256 divided by 512. So that comes out as a half. Yeah, so it equals a half, which is greater than 0. So therefore, it is a minimum turning point. At this point, if that wasn't an invalid answer, you could have put the negative in here. And you see if you put the negative in, that would have come out as a negative number, which would be a maximum turning point. Yeah, so if you get two numbers that are valid, just check both of them to show which one is the minimum. And it's find the minimum value of p. Okay, so if I answer the question now, let's just put all that together. So answer the minimum value of p. So I'm saying that p is going to be equal to 2 times 8 plus 128 over 8. So that's going to be 8 times 2 is 16. And to that I'm going to add on 128 divided by 8. And that's going to give me 32. And it's in centimetres. So quite a big question, but actually quite a nice one. I think the hardest bit is getting the flow. So to me, get your equations, write them down in such a way you can substitute, and in such a way you can differentiate, and then differentiate and differentiate again. That's you get a big bit already, and that is actually worth 2 marks right away, because you've got this, and you've differentiated it. So 2 marks right away for this. Stating this, that you're looking for equal to 0 and starting to rearrange, you've got a mark for that, and then a mark for actually finding out that it's x. Then you get a mark for verifying the nature, tick, and then a mark for your final answer, tick. But it's just getting this flow, the equations, the differentiation, the nature, and your final answer. Some things it won't ask for the final answer, it just wants to know what the value of x is. That's fine. Other times you're going to have to take this and substitute it into something else. But that's a good question to do. Don't be scared. I know it's 6 marks in one go. This to me is the key to unlocking this question. Is just having this, your shop set out. You need this for your final answer. You need this for your differentiation, and you need this for the nature. So once you've got that, you're just going to use each of these in turn. Use your differential, use your nature, and then back to the beginning, substitute in, get your answer. So yeah, hope that's helpful.